Yeah, I'm ready.
Welcome to week 8. Let me hit a button. I've done more work in our Moodle page. We have all but one math topic. We have graphing to do at the very end. We've done a little bit of graphing, but only of lines. So we're going to graph more types of equations at the very end of the class. But except for that, then everything is here. So in the applications and division of polynomials, we started that topic Thursday. We should finish it up today. And then more about exponents will start probably on Thursday. Maybe we would get to it today, but I don't think we're in a rush and there's really no need to transition today. We haven't done scientific notation. That was officially in a earlier week, but we skipped it because of weather, and we'll finally come back to it now because it is sort of about exponents. And then we'll talk about square roots and how to do arithmetic with them, and finally how to use them as a different style of solving equations that have x squareds in them. So that's what's coming up later. I'm going to close this tab because we don't care about that topic now, but it is here if you want to look at it, budget your time and so on. Just as a quick heads up, there's a lot of videos. I have no idea why all of these different math YouTubers not only make so many videos about square roots, but are so bad at putting them into playlists, and I have to link to them individually. So it looks a little overwhelming, but that's okay. You can find whatever videos you like and use the ones that work for you, skip the others. Here we go. The homework for Thursday's topics is not that much. So if you are getting caught up on homework, then you're not going to get swamped with more just because there's a lot of videos. Doesn't mean there's a lot of homework. It's just people explaining it again and again. Okay, so that's sort of our plan for the next 2 classes. With our applications and divisions of polynomials, then we've been dealing a little bit with word problems. We had a page that looked like this with different ways to use word problems. And we're talking about what they call rational expressions. So a ratio where the top and bottom are both formulas with letters in them, or possibly have letters. And then the last thing, which we haven't really done, is talking about putting word problems into rational expressions, how to take paragraphs and make these things out of them. So that's what we're working on mostly today. If you are trying to do more than the GED, then factoring and simplifying these, or even adding and subtracting them, since they work like fractions, adding and subtracting is harder than multiplying and dividing because you need common denominators. So all of that is stuff that you could get under your belt now if you are thinking of taking STEM classes, but the GED doesn't actually ask you to do that. The solving of word problems, then I'm not sure, I've been told this isn't on the GED, but if you can do this, then it's very good reinforcement for all the other stuff. So don't just skip it entirely because you're only here for the GED. Okay, so with that in mind, let's move on to the next whiteboard. So this was our applications of multiplying polynomials. Now that we are looking at dividing them, we had a bunch of stuff already, and now there's new stuff at the bottom. So what did we do already on Thursday? We did a review of what fractions are and canceling. We talked about finding all the factors, making like a horseshoe, compared to the tree that gives you the prime factors, and that sometimes when you're reducing one strategy or the other will be the easier one to do. So if you're good at both of them, you have options. and they will flow nicely. But if you only do one of them, that tends to be good enough. Yes, I see an arrow. Let me remember to put this in chat so that people don't have to. Come on. Copy link. Go through. Okay. Then we did some example problems and we treated them like fractions because they are fractions. They are just annoying fractions because they have letters in them. So in this top equation, not sure how well you can see my mouse. So in this top equation up here, then we took the bottom and we made two factors, one of which canceled out. Very, very similar to if we were doing instead a fraction that had a denominator that we could turn into two factors and then have one of them cancel out. So same idea, but it just looks worse because you have letters and polynomials. Then we had one that was a little more complicated. It involved taking something out from the whole part on the top before doing the factoring. So an extra step we hadn't seen before. So first we took 2m out of all three parts. And then we factored this thing as well as the denominator, and then could figure out what to cancel. So we did lots more examples. I could do more review and more warm-up, but we're going to do them now in the word problems. So now we're at the bottom of this whiteboard. I'm going to bring everyone to me if there's someone else here. And we're all sitting where I can't look at you and the screen at the same time. See if I can do this. Okay. No, that's terrible. Okay, I'll go back where I am. You two are just like staring at the back of my head in a menacing manner. That's
Sorry, I had to charge my computer.
I don't have
Okay.
an excuse, this is my, I call this spot.
You call this, yeah. Okay, anyway. As a heads up before we get started, the textbook that is free, the OpenStax textbook, has a table that will fill out. And the order that they do things makes sense if you were sort of inventing how to do this, but hadn't actually done any of them yet. You would think rate times time equals distance. So let's set the table up with that type of multiplication. It just rolls off our brain, off our tongue easier. 2 times 2 equals 4 seems nicer than like 4 equals 2 times 2. 4 divided by 2 equals 2, something like that. And it sort of looks forward in grammar. But when you actually do these types of word problems, the key thing is always the time. The times are equal, or the times add up to this number, or something like that. So the nicer textbook, the XYZ textbook, rearranges its tables. And it puts the time on the far right so that what you're actually caring about is easy to see on the edge. So notice that in its table, distance and rate are first, and then time is over here. So that means that the equation you have is that mental distance divided by rate equals time. You write it up there so you can see it. So that's the way we'll actually do things. Okay, lots of introduction. I'm gonna do two problems kind of from scratch. There's nothing on the board. And I'll talk my way through them and hopefully they will make sense. Then all of you will join the whiteboard. And I've spent lots of time saying, oh, well, maybe like this goes here and this goes here. Who knows, right? I'm not gonna give it away. First, you'll put these items on the left side. No, that's the right side. On the right side in the table. And then everything else you need is here, and you just have to rearrange it like a jigsaw puzzle. You did this with the midterm ones. So there's a whole bunch of them, and you can all work together and talk a lot. I can turn off the recording so that if you don't like talking when being recorded, that's okay. But they get kind of more complicated very slightly as they go. So that's our plan. I will do two, just writing it. And then enough of me talking and you just watching, you can all grab your mice and move things around. So with that introduction, let's get started. A boat travels 30 miles up a river in the same amount of time it takes to travel 50 miles down the same river. So upstream, the distance it goes was 30. Downstream, the distance it went is 50. The current is 5 miles per hour. So if R is the rate of the boat itself, how far its engines are pushing it, how fast its engines are pushing it. If we're going upstream, we subtract 5 because it's fighting the current. And if we're going downstream, then we add 5 because it's being pushed by the current. So what is the speed of the boat if the water was still? Notice, as I warned you, that it gives you the information in these two tables. And then at the end, you do some division and find out the time. And we'll do something with the times on the other side. So this time is 30 divided by R minus 5. And this time is 30 divided, or 50 divided by R plus 5, I think. Everyone okay with how I took the paragraph in English and turned it into a table?
Yeah.
This is a little strange. Let me make a comment. Normally, what you've been trained is you take the paragraph and you turn it into an equation. And we're not there yet. There's no equal signs. First, we're making the table as this intermediate step, and then we're making the equation. Okay, what do we know about the times?
We're the same.
They're the same amount. Well, that's a terrible one. Same amount of time. So in this case, we set them equal to each other. So 30 over R minus 5 equals 50 over R plus 5. I don't know anyone, except someone that just spent all night doing this type of homework problem, that would look at the paragraph and come up directly with that equation. Right? There's nothing in the paragraph that makes you want to write that. So that's why we do the table first as our intermediate step. Okay, how do you want to solve this? There's lots of ways to solve fraction equals fraction. I'm going to show you two of them, because one of them you probably will like better, but the other one relates more to what we did before. So I want these things to have look like polynomials, not look like fractions. If I take the one on the right and multiply it top and bottom by r plus 5. That's going to make I'm sorry, not. Am I trying to say this? I'm trying to do something that I shouldn't do. Never mind, forget that. Let me just ask you this other one then. So if I was instead, I'll jump to the one that everyone likes. If we had something like x over 3 equals 2 over 5, how would we solve that?
Multiply the top and bottom by 3. 3 over, or x over 3.
Yeah, you're trying to follow the path I was about to follow, and I'm actually gonna show you the other way. This will make you probably go, aha, once I show you. So there's,
You have one more guess?
yeah,
Do you cross multiply?
yes, cross multiply. Everyone likes cross multiply. People like cross multiplying so much, they try and cross multiply when they shouldn't, right? If you had a similar thing of x over 3 plus 2/5, you can't cross multiply there because you're adding, you're not having a proportion. A proportion is fraction equals fraction. And that's not what we have here. So there's a danger of showing you cross multiplying, because you might start cross multiplying when it's not a proportion, just because it's fun, easy. But this is the right thing to do, so I'm not going to try and do something else and say, don't do this. Okay, so if I want to do my cross multiplying, then I'm going to take one diagonal. And multiply it. And then I take the other diagonal. And multiply it. And if you remember from earlier math classes, you get like lots of superpowers here. Since it doesn't matter which side of the equation these are on. Right? 6 equals 5x is the same as 5x equals 6. Then you get to pick which diagonal do you put on the left and which diagonal do you put on the right. It's also true that when I multiply, it doesn't matter which order, right? X times 5 is the same as 5 times x. So that means whenever I do this, I can pick to put the x on the left-hand side, because for most people, the way our brains work, that's the nice thing to do. And I can make it look like 5x instead of x5, because I'm more used to that. Okay, is that a good review of cross multiplying?
So at this point, you're now gonna divide each side by 5.
Yeah, now to finish this, I would say I'm not done yet. And x equals 6/5, or 1/5, or so on, right?
Okay.
Okay, so that's our distraction of cross multiplying. Okay, back to our real problem. So if I cross multiply now, it doesn't really look like it saves any time or energy or mental effort to do one diagonal versus the other. Does it help for me to color code? Do you want me to do colors again? So 30 times r plus 5 is 50 times r minus 5. Everyone happy now with that cross multiplying step?
Simpler than I was probably gonna go.
Yeah, I was thinking of doing a different method, but it was just going to be long and awkward. Okay, anyway, 30 times R, that's 30 Rs.
Isn't that what you kinda already had to be in?
Isn't what?
Isn't that what you kinda already had in the chart?
Isn't that what no. The 30 on the chart is with the R minus 5 in division,
Okay.
so they didn't match up that way. Okay, 30 times 5, I need to distribute my 30 both places. So 30 times 5, 3 times 5 is 15, so 150. So there's a 0 there. 50R minus 5 times 5 is 25 with another 0. Okay, everyone with me so far?
Yep.
Now, which side do I want to have the R's end up on? Should I subtract 50 or subtract 30?
Subtract 50.
Does it matter?
It doesn't really matter.
But
Sometimes it
you,
matters.
but you avoid negatives if you do the 50.
Yeah, I don't like negatives, so correct. But I'm in Anthony's camp. I don't want to have a negative thing there needlessly. So rather than subtract 50 and get negative R's on this side, I'm instead going to subtract 30 from both sides, and then I still have 20. I can also, if the R's are going to be on this side, put the numbers here. So that means I should add 250 to both sides. You could do this in 2 steps if you want. You could deal with the R's first and then the plain numbers. I'm just sort of running out of room. So we have 20 R's and 250 and 150 is 400. So we'll divide both sides by 20. And we get 20, it's a word problem, so I should label it. It is miles per hour. As a side note, I only box the 20 miles an hour. I don't box the equals R. Because whoever gave me this problem doesn't know what R is. R is this thing I made up as I was doing this.
Why?
When I decided to
No,
pick.
why?
Why?
I don't know why. Why'd you put the R in it?
Because for me, R and rate are nice. You could use X or Y or whatever, it doesn't matter.
How
But
do you know to do cross multiplication from that?
because I have fraction equals fraction. And that's the easiest way. Right, notice what cross multiplying does is it takes an equation that has fractions and changes it to an equation that doesn't have fractions. As fractions, not anymore. And I like that because I don't want to do math with fractions.
Is that really the only time you should cross multiply is when it's a fraction equals fraction?
Yep.
Like, not
And are those
those ones?
usually known as ratios or
Proportions.
proportions?
A ratio is something that looks like a fraction, but the top and bottom have different measurement units. Miles per hour,
So
pages per minute, something like that.
so cross multiplying doesn't work for ratio?
It does.
Oh, it does.
It does. And it works for these weird things that have letters in them too. It's not just plain number fraction. But anytime you have something that's the shape of fraction over fraction. And so fraction equals fractions, you can cross multiply.
Oh.
And that's why we like rates and ratios, and that's why we like the kind of thing we're doing over here, because we can use these fraction tools.
Gotcha.
So in a way, having this type of thing looks scary. I'm making fractions, there's letters in them, but we get a lot of power with fractions. There's things we can do with fractions that we can't do with other things, so. There we go. Do you know why cross multiplying works? No, okay.
Isn't that because when you have. So I'm totally gonna go out on a limb and basically guess on this answer. But a fraction is technically a division, right? So when you have two fractions, you have to swap one of them to multiply across. It's just easier to cut the middleman out and just cross multiply. Or am I just making up my own language over here?
Sounds-
It sounds legit, but I've had the issue of being like. The blind leading the blind in simple situations, so.
Okay, there we go. So I'm gonna grab that picture. And put it. Off to the side even more. Okay, so 2 times 10 is the gray. Diagonal. 4 times 5 was the greenish blue diagonal. Someone is claiming that does 2/4 equal 5/10? We can check. And we're gonna check by doing this multiply in an X-shaped game. And if the 2 times 10 equals the 5 times 4, then the original thing is also true. Right, that's sort of the most primitive version of cross multiplying. There's no letters at all. It's just, are we checking if 2 fractions are equal? So I could do this a longer way. I could say that 2/4 might be equal to 5/10. Remember, we talked about different ways to add fractions. It was like a brute force method, and there was a factor tree method and things like that. I'm just gonna brute force this. There are common denominators of 4 and 10, but I'm mentally lazy. I just know if I multiply each denominator by the other, it's going to be the same. I don't even have to know that's 40. But if I do it to the bottom, to be fair, I have to do it to the top. Everyone okay with what I've written now?
Yeah.
So then this becomes 20/40. And is that the same as 20/40?
Hmm.
And if you look carefully, this is just that. And this one is just that. So all we're doing is brute force making the denominators match, but we're not writing the denominators because we know they're going to match. We're forcing them to match. It's not an issue. So instead, we're just writing the tops. The numerators here. And that's what the X shape comes from.
Okay.
I think I like my answer better.
No one is going to ask you. Why does cross multiplying work unless you have kids? But you should be able to be happy that you can understand why it works, even if you forget it tomorrow, that it's not some like mysterious thing. There we. Okay, ta-da, lots of good questions. Any other questions about this one before I do the second one?
No.
No, okay. People in Zoom, any questions before I do this next one? Gonna make this a little bigger. Okay. Okay, so Tina is training for a biathlon. To train, she rides her bike 15 miles up a hill. So that's our distance. And then back down the same hill. So same distance, top and bottom. The complete trip takes her 2 hours. I'm not quite sure what to do with that yet, so I'll just underline it for now. Her downhill speed is 20 miles per hour faster than her uphill speed. So for uphill speed is, we'll just call it R, then downhill is R plus 20. Everyone okay with how I took the paragraph and filled in the table? Okay, now I do my division. So on the top, we have, again, correct me if I make sloppy mistakes, 15 over R and 15 over R plus 20. Okay, now back to the paragraph. What do I do with the times now?
Well, we have to finish the question. Right? Finish reading the question.
The question is how fast does she ride uphill? So that will just be my R.
It wouldn't be R negative one.
R negative.
Well, if she's, oh, I guess it would just be R. I was thinking that it would be, she was 20 miles per hour less going uphill.
I could make it to the bottom is R and the top is R minus
I
20,
see.
but then when I get my answer, I have the wrong answer and I have to
Right.
remember, oh, I have to take, add 20 to what I got, or take away 20 from what I got. And so this way it's just nicer. I'm not always going to do that. And the ones down below, sometimes I can't afford to make the plain letter the thing that it asks me for.
Hmm.
So anyway, I have 2 times. What do I do with these 2 times here? Before they were equal in the previous problem, but that doesn't say now that it is the same time going up and down.
Are you gonna need 2 different equations?
No.
Oh. I wanted to do 15 over R equals 2 and then. For 2 hours and 15 plus over
You're on the
R.
right track. The complete trip takes 2 hours.
Right.
So what we have is time for uphill plus the time for downhill equals 2.
Oh. Okay.
Well, that makes more sense.
Yeah, damn it.
So if you want to write something like that with some words, you can do that. Because it is a kind of awkward thing if you haven't done this a lot to say, oh, 15 over R is my uphill time. And 15 over R plus 20 is my downhill time. That just doesn't look as natural. But it is the right thing to do.
The 2 over 1, you mean?
The 2 over 1 I'm doing just because I know what's coming next.
Oh,
So I want not to do cross multiplying. I don't have fraction equal fraction anymore. Right? There's no proportion. Now I'm trying to add fractions. Oh, not as nice. But I know how to do it. I need common denominators.
20R and R.
So yeah, I have to make this one also have an R plus 20. And this one also have an R. And if I do it to the bottom, I have to do it to the top. With me so far?
Yep.
So that gets me 15 R plus 300. And 15R. I guess I don't need 2 after 2/1 after. Whoops, that's not an eraser. Okay, are you with me with this step? Is it okay that I distributed? As well as everything else? You could make 2 steps out of that if you wanted. I took the 15
Wow,
times
right.
R and the 15 times 20. Okay, now. I have something over this plus something else over that, so I know how to add those. So 15R plus 300 plus 15 more is 30R plus 300 over all of that. Now I will write this as 2/1. Now finally I have fraction equals fraction.
Now you cross.
Now I can cross multiply. So. Fine, show me some colors, okay. So 2 times R plus 20. Equals. Well, 1 times something is just the something.
Right.
Everyone okay with the cross multiplying stuff?
Yes.
Some people are taught to think of this as clearing the denominator. If I will have a fraction equals a whole number, because the 2/1 was a whole number, and I want to get rid of the fraction, I can multiply both sides by the denominator. It sticks itself on to the whole number. And this part stuck onto the 2, and then disappears from the other side. So if you've heard the phrase clearing the denominator, that's what they're talking about. But for most people, you're so used to cross multiplying that just think of cross multiplying and you don't need a second name for the same thing. Okay, then we're not quite done, but we're getting closer.
Right, so you can just, when it's a whole number like that, you can just turn it into a fraction and cross multiply and it's fine.
Yep, because a whole number is whole number over 1, right? We just did 2/1.
Yeah.
Okay, now let's make this nicer. I'm gonna go up a little. So we have 2R times R is 2R squared, 2R times 20 is 40R. Equals 30R plus 30. Remember, I want to get this type of equation, something equals 0. So I'm going to take away the 30R from this side. And I'm going to take away 30 from both sides. So I wind up with 2R squared plus 10R minus 30 equals 0. You might not remember why I want something equals 0, but just, is it okay how I moved from one to the other?
Yeah, you lost.
I never saw the plus 30. Like when they just leave the 30 there.
Well, I could, but I want the other side to have nothing in it, be equal to 0.
Oh, fine.
And the reason we did that was we did a bunch of these up at the top a little bit if you scoot up. If 2 things multiply and the product is 0, they multiply to 0, at least one of them has to be 0. That was called the zero product property, but you have to have a fancy name because it's math. So now that we have it all something equals zero, we're going to factor this. I'll have a 2r plus or minus something, I'm not quite sure, and a single r. Let's see. Let's just do this the long way, because if I narrate it out loud, I'm gonna lose you. So we want to factor 2r squared plus 10r minus 30. So I'll go over to the side. Oops. Remember that we thought about a box. One box, there we go. And we wanted the area of the box to be the first number and the last number multiplied together. But we had A and C when we did this a whole bunch that other day.
Right.
So the area is going to be negative 60. The fact that it's negative doesn't really make sense as an area, but again, we're just using the geometry to help us remember the routine. And then we had two sides, an L and a W, and they add up to the middle number, to the 10. Does that ring a bell? It's been a week or so. So what two numbers are there that multiply to negative 60, but add up to 10? Again, I screwed over a little. It could be 1 and negative 60, they multiply to negative 60, but they don't add up to 10. 2 and negative 30, no, that would be 28, something like that, no, okay. 3 and negative 20, still doesn't add up to 10. Does 4 work? 4 and negative 15. No, doesn't add up to 10. 5, negative 12. 6 and 10. 7, 8's not gonna work. 9, not gonna work. What am I missing here? 2, 10. Could have taken a 2 out from everything. Did I mess up earlier? 15. 2 is 300. Ah, yep, I had a error earlier. This was supposed to be 300, not 30.
Oh, yeah,
Ta-da. Okay, so that means that this is 300. And this means that that is oops. That is 300, and that is 300. And that means that that isn't 60, but 600. Okay, so now we can keep going. We made a mistake, but it's no big deal. Okay, I want some bigger numbers. Oh, I think I can just see it. We're going to go down and have 10. I mean, not 10. We're gonna eventually have 20 and 30. That's a terrible two. Sick. Okay, 20 and 30. And if we want overall the 10 to be positive, then we should have that be the negative of the two. So there we go. Okay, so we were just told to break apart the 10R into plus 30R and minus 20R. And then we factor by grouping. Oops, minus 20R. One, I can turn on my brain. And then. Whoops, no, that's not an R. Okay. Now I think I fixed all my mistakes. Everyone okay with what I've written on the board, now that I'm done making errors in front of you?
I'm as okay as I can be, cause I got a little lost in my comment.
Okay, so if you haven't done the factor by grouping in a while, then we took the 2R. That look a little flatter. And the minus 20, they came together here. We're sort of unfoiling. This part. The fact that we wanted a plus 30 and a minus 20. That came from over here.
So that one confused me. How did we go from negative 600 all the way to 30? Or one.
I just skipped a bunch to save time. So we could have had 10 and 60. We could have had 12 and 50. But I could see, oh, well, we need them to only be 10 apart. So that's going to be 20 and 30
Okay.
Cause that 20 times 30.
is 600.
Man, it's a lot of steps.
It is a lot of steps. That's one reason why. Again, for the GED, you just have to be able to translate them into the expressions. So once we got to here. You could stop,
Hmm.
because on the timed test of the GED, you don't have enough time to do all these other steps.
Oh,
They might ask you how to factor polynomials as a different problem. So the fact that I just gave you some review on factoring polynomials was not a waste of time. But they're not gonna ask you to do so many steps on problem. That would be the problem everyone's guessed.
hmm.
Okay, but let's finish up. So we know because of that zero product property, that one of these two things equals 0.
Those English muffins.
You want me to switch this thing back on?
Yeah. I'm gonna try one.
Now, if we have two R minus 20 equals 0. That gives us two R equals 20, so R equals 10 miles per hour. That sounds like a reasonable answer. What about the other one? Can we have a rate of negative 15 miles per hour? No, that's nonsense. And this will very often happen.
So would
You get two possible answers. And because this is the type of situation that only has one answer, then the second thing that works for the math doesn't work for real life.
Okay,
What do you do in that situation?
You box the one that works and ignore the other.
Okay.
So this is sort of like mathematical sediment at the bottom of your hot cocoa mug, right? It's just part of enjoying the hot cocoa, but it's not really, unless you're my older son, part of the experience, because he likes to spoon it out and eat it.
For my kids.
So,
so if this wasn't a word problem, but you're doing this, would they both be right?
if they just told you just what you see here, start with this equation and factor it, then
Yeah.
you would write them both.
Okay.
But as far as when it's practical in real life, it's almost always this type of thing, where one answer of the two will make sense in the situation and the other won't. And usually it's a positive and negative. You might, depending on where you go in math, have other ones, other ways to say only one makes sense. So how much are you investing? The answer that's like $100 is fine, the answer that's $1 trillion is not fine, or something like that. So sometimes they're just, one is ridiculously large, but usually it's positive and negative. Okay, so that was like a fairly easy one I did in the beginning. It was still a lot of work, but it fit nicely all in one little part of the screen there. And then this giant one that just kind of went on and on and on and on. And I wanted to show you both, like the easiest it could be and the hardest it could be. So your job now is to, let me move all your stuff down a little bit.
Sourdough.
So your job now is to do these by yourself. So we're starting at number 9. I'm gonna be rude and pull everyone towards me.
Well, the goes way or fine, doesn't matter.
Yep, you put them on and then put the batteries. And you can rub butter on it, because it's an English butter. Okay, so work together, talk a lot. I will turn off the recording. First, you're going to fill in the table using these bits over here. Okay, this goes there or something. And then you're going to reassemble the jigsaw puzzle of the broken equation.
Which, is this in week 8, this? Is my board?
It's a 7 and 8,
7.
one that says
Application,
Yeah.
20 miles per hour faster than another. So that's gonna be.
This one's,
that one, yeah.
So that. One goes 285, at the same time the other one goes 255, yep. Alright.
Once anyway, so 3.
give them exciting commentary like it's some sort of horse race. The R plus 20 is heading up to the right side.
Hmm.
Alright,
I
so
don't know how to move it.
where's the, oh, 285R. So. Is that R plus 20, is that connected?
One of the diagonals is 285R, and it doesn't matter what side you put it on.
Yeah. I think, yeah. Yeah, this side. Because the cost multiplies by R part 20.
I think that's already together
Just,
up here. So you can keep
Mhm.
set.
oh. Yeah.
I thought the R plus 20 was. Oh, but because we cross multiplied,
Mhm.
oh, I see. Right.
That's why I drew out mine.
And multiply them together in here.
Yep, you're on the right track, that's still
And
280.
the same with, still the same with R. Mm. And this should be, oh no,
Well, where'd you go?
where is, yeah. And then,
She just take that
She
51.
took a 5100 and hit it. Where did you hide it?
Just chucked it in the garbage.
oh yeah.
This was.
I don't know where it's gone, teacher. I just kick it and then gone. There is, I don't know where they are.
If
Sorry.
you undo, it will only undo your things. Do you see that?
Undo.
arrow under
Okay,
the-
I try. Okay, I try. Oh yeah, that's it.
It is.
What the? We're gonna minus 255R,
Mhm.
but
Yeah,
Oh, but it's gonna be one.
we
That's gonna make it a negative.
we can move 255 to another side.
yeah, another side.
For
Sure.
it is minus, yeah. So we still have 5,100. Yeah, the same.
And how many Rs do you still have on the other side?
30.
Yeah,
I'm just confused about the.
and divide them.
So then.
Divide them by 30.
Divided by 30,
Yeah,
so it's gonna be one.
Yeah.
Yeah.
Are we missing an equal
you
sign?
might be missing an equal sign. You can copy, I stick it somewhere else. No, we're just missing the equal sign. And I gave you some red herring numbers this time, but they did not distract.
Oh, okay, so these ones are. Some
Those are just ones that you
placebo
take off to the side.
effect, okay.
Okay, great job.
We don't need to start with the table.
Ready to try the next one?
Yep.
Notice if you are really having this, this is the first time it asks for both speeds. So you'd have to say 170 and 190 miles per hour,
Where'd the 190 come from?
because it's 20 more than the other one.
Oh,
So just to be tricky, it phrases it that way. Okay, next one. Let me grab everything. They're up. Okay, so if someone is training for a biathlon. She runs 8 miles over the same course, 2 miles on level ground and 6 miles downhill. And she runs a little slower, 3 miles an hour slower on the level ground than downhill. If the whole course takes 1 hour, how fast does she run on the downhill part? A slightly artificial problem, because someone like picking her up in a different car and taking her back where she started, you can't go only downhill. Wind up where you parked, but whatever, it works for her. It goes to the other bus stops. Okay, if we scroll over, then people have already filled out the table. So how do the times relate to each other? They're not equal anymore.
hmm.
Oh, to complete the course for 1 hour. So. Yeah, one, equal sign, one of the one. Cause I think it's.
It's a great first step.
Why, why is that the first step?
Because the 2 times had to sum to 1 hour. It takes her 1 hour to do everything. So when you filled out the table to the side, those were the 2 times, they have to add up to 1.
Okay,
So we need those fractions to have common denominators, because we're adding them. Don't jump ahead, Basumsuk, we're not there yet. First, get some common denominators.
so. This one,
That looks good. So we got that by multiplying top and bottom by r. Slightly above.
oh, and this one. That,
Mhm.
that's still equal 1.
It still equals 1, we haven't done anything with the 1, so it's just 1. Which is nice, 1's a good number.
One is the loneliest number, it's the only one.
No, I think 0 is more long. This one itself.
Right, 0 goes to hero. And 0 becomes a hero.
The actual song.
Yeah,
It's
it's from Hercules.
oh, I should just watch that the other day too. Not just.
Okay, so if we clear the denominators, that was the step that kind of combined adding the fractions and cross multiplying. We're going to multiply the whole thing in that second line by r times quantity r plus 3. Yep, grab that, assume so you were just there. The 1 times r plus 3. We're not there yet. Yep, but the one Anthony has, oh,
We're all having technical difficulties.
so put that on the right side, because we're multiplying everything on both sides by r and by r plus 3. And that gets rid of the denominators on the left hand side, which makes it much more friendly. And you just have a 2 times r plus 3 over here.
Oh. Right.
Yes. Good eyes.
Oh, yeah. This one RR,
So that's gonna be r squared.
And the one you can ignore, times 1 doesn't do anything. R times r is r squared. I'll take that one out of there, we don't need the one.
But it's there.
Okay, and then what happens with the r time r multiplied by 3? Yeah,
how many parentheses are in that?
no, you just need a plus sign between
Of those,
ta-da.
puzzle. Oh,
Did I not give you another 3r? It looks like we need to. So,
it.
yeah, just highlight it and copy and paste.
before. How did that go to this?
Looks like I forgot to give you a 0. This one should have been a 0.
There's 2 zeros right over here.
Ah, okay, I'm just not zoomed in enough. Okay, so we're getting 0. Don't jump ahead so much. So we have the r squared. And you have 3r here. And 5r over, no, this isn't quite right.
Yeah, I'm so confused with where I was lost.
So, okay, let's do that here. So you have the r squared, so far so good. Then you have 3r here, and you have 8r there.
Yeah.
So 3 minus 8 is gonna be -5. So I didn't need another r squared, everything was good, okay. These things we made extra copies. Okay, now you can have factoring. All this stuff was extra distraction, okay. So what could R be? 6 or -1, right? -1 is nonsense, so 6 must be right.
So wouldn't this 0 right here be 6?
Cause we moved the 6 to the other side on that line, see the -6 right over there. You could do more steps if you wanted to move the 6 over as its own step. Okay, let me write a little bit at the end. So we look finished. So R equals -1, which is nonsense.
How do you get R equals -1?
One of these two things has to be 0. Because they multiply to make 0. So we could make it 0 with a -1, but that doesn't help us. She's not running backwards or anything. Or are we equal 6, and then is it miles? Yes, we're not in the metric system, okay.
Some like reading between the lines kind of stuff.
Great job, good teamwork. Oh, do another one, you're on a roll.
Sure. I mean, do we have anything else we were trying to cover this last period?
Okay. This is just a comment that we made that one of these is negative, it doesn't make it. No, there's nothing more productive than just giving, whoops, right? Giving you the practice you need. This stuff. Okay, Jerry's turn to train for a triathlon. He jogs 1 hour over a 9-mile course. Of that 9 miles, 5 is downhill and 4 is on level ground. And Jerry thinks she runs 2 miles an hour faster downhill than on level ground. So stare at that. Do your table over here. Not for 9 miles.
So 5 of it is downhill. 4 is level ground. He runs 2 miles faster downhill. And these just look like they go there.
Okay, so now that you have your 2 times as fraction things, rational expressions. And how do they relate to each other? They add up 1 hour.
Will they both add up to 1 hour?
That's what the word problems. In a Zoom, out the little so I can see what you're. That looks good. That is there for Zoom, so. I'm gonna pause you for a moment, just so you don't have too many extra pieces and get confused. So when I designed this, I was more explicit with things. Getting common denominators. Okay, now you can keep them. We're again clearing the brackets. We're multiplying both sides by r and r plus 2.
For a little bit.
That makes the denominators go away, which is why it's called clearing the fractions, because we don't have fractions anymore.
Let it pass. When I sit here, my heart is.
Some stuff up so you can see it. Mhm. We need to finish the clearing the fraction step.
I feel like this is the part that I always get stuck.
This one? Like that?
No, not yet. You need the right side. You've done the left side of that fourth line. You got rid of the denominators. But to be fair, we also multiplied the 1 by both r and r plus 2. Yeah, that one is sketchy. There you go. So what values
Pass.
work for this? Either r is negative
Different
1
negative 1,
or r
It's positive.
and positive 8.
and are we still on miles per hour? I have now forgotten.
Yes, we are.
Okay.
Okay, so how come in the parentheses, it's +1 and -8, what the answer is the opposite?
How did we get, okay, so here we wanted two numbers that multiply to -8.
Yeah.
And add up to -7.
Yeah.
So we could have 1 and 8, we could have 2 and 4. And that's it for factors of 8. So where do I put the negative signs? So that this might add up to -7, because that's the middle. If I do it that way, it's gonna add up to +7. But if I do it this way, then it adds up to -7 on the top. If you wanted to write the other step that goes in here, then you'd say r squared plus r minus 8r, that's breaking up the -7 in this manner, right? -8. Are you okay with breaking that apart?
I think this part right here just confused me.
Then we did the factor by grouping.
That's the part that confused me the last one.
we take these two and say what's in common. The only thing in common is the R. And then we take the other two and what's in common, a -8. And lo and behold, the parentheses parts will always match. And then we unfoil. And these two things come together. We get an R -8. It's an R +1. The order doesn't matter.
Okay.
So that was the steps. Make that look better. So that was the steps in between there.
Well, to get to that last one, we still have to figure out more.
Once you get to the R squared -7, R -8 part, yeah.
Yeah.
If you've done a bunch of the homework, then that's a fast thing. You can just look at it and move to the next step like we did. But if you haven't done enough homework to really get smooth at it, then just go ahead and do the bulky process on the left side. It will always work.
Okay.
It's kind of like. Um. I think of a good metaphor. When I'm teaching the homeschool kids about baking on Wednesday morning. Some of my volunteer work, then they really want to follow recipes, because when you are like 3 to 8 years old, it's important to follow all the rules, otherwise you're gonna mess things up, it won't taste good, right? But when I am baking, I'm just like, oh, this batter is kind of dry, let's add more water. Oh, this batter is kind of wet, let's add more flour, right? So if you are good at it, you know kind of how the shapes go and can just make it like it's supposed to be. That's the equivalent of on this side, just. There's gonna be plain R's, because I can't multiply and get R squared if there was like a 2 there or anything. So what are two things that multiply to 8 and are different by 7? Well, 1 and 8.
Okay.
So you can kind of see how you don't have to go through all of this stuff on the left side if you had it. But if you are not that fluent, because you haven't spent hours of your life doing this homework, then this will always work.
Good.
Okay.
It's a lot of steps.
It is a lot of steps. Notice we saw some patterns. When the word problem involved the times were equal, then you didn't have to have this many steps.
Right.
It was just a cross multiplying. When the word problem was the times sum to an hour or sum to this many hours, then there were more steps. You had fraction addition. And that slows you down. Then you have 2 steps. We don't have time to do more, but there's one more kind of problem. So if you want, you could. Over the weekend. Oh, no, we did finish. Ta-da, there's no more. Okay, so. Our last thing was this optional subtopic. About. Flows. The pipe puts water in and takes water out, and if both pipes are open, what happens? That kind of thing. And I don't have time really to show you a demonstration now. This is an optional subtopic. It's not something that the credit classes that you might go into 95 will talk about as much, if at all. It's not something the GRE has, but it's the other famous application for using these fractions with letters in them. So just sort of to be a well-educated person, if you go to the nice textbook and look at rational expression. Application. Then, not only do we have the ones we've done, but we have these pipes. And you can read through those and see how they work. And the weird thing that happens is you have to set up an equation that you can now see towards the bottom. Where it's 1 over something. Plus or minus 1 over something, plus or minus depending on the word problem. Equals 1 over and then a letter that's the total time it takes to do this, or the total amount of that thing. So it's this weird thing where everything important happens on the denominators. So if you want to try and wrap your brain around that. You're welcome to. If you don't, no one will ever care.
Will it help with the homework?
No,
Okay.
no, it's just sort of to be like ultimate well-rounded person. Like, this is the other application that we do with this,
Oh, okay.
other than the. Things we just did where you're doing this speed and this speed, they fit together. Okay, so ta-da, we filled up our time, that was great. Again, when we meet next time, then, oh, let's look at the homework real quick. Not very many things, but again, each of the problems will have a lot of steps. So budget a bunch of time for this. And then we're nearing completion because our next topic. Playing with square roots and exponents goes much faster. These are quick, short problems compared to what we did today. So this is like the hardest it gets this term is what you did today. Which is why I took the time to make all jigsaw puzzle things, because that's
I
what
like that though.
Yeah, that was pretty cool.
Okay,
Okay,
ask me
so-
questions if you want. I'm gonna stop the recording. Have a great 2 days. See you Thursday.